Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 5th. Looking at significant wave heights for the North Pacific Ocean, we don't see a whole lot going on. In fact, one can almost make out where high pressure is control of the atmosphere with no significant wave heights of interest going on. A little bit of wind perhaps off of the Pacific Northwest and midway between California and Hawaii, but not generating any seas of interest. Another area of wind, a little bit stronger off the Kuril Islands, all pushing to the north, generating, maybe 20-foot seas, but all aimed at Kamchatka and doing nothing for our forecast area. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough, a dip in the jet stream, just like that, there and there. But these are dips in the southern branch of the jet stream. You want it in the northern branch, and if you follow the jet stream here, it goes up, and that's the northern branch up there off the chart, all either north of the Bering Sea or over Alaska. That does nothing for swell production. In fact, when you have a split jet stream pattern like this, northern branch up here, southern branch winding along down here, typically you get high pressure in between the two branches of the jet, and that does nothing for swell production. Anyway, we'll roll this out. This is as of Sunday. We see the split pattern. Now notice, let's go back right here. Here we go. Monday, a backdoor trough forms. That is a trough that's over land and then starts bulging south. And this is in the northern branch of the jet, so that could help support a counterclockwise flow aloft there. And also down at the surface, and of course, the counterclockwise flow is the hallmark of low pressure. Low pressure generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, produces swell. Swell, when it hits your beach, produces surf. We get into Monday night. Tuesday, there we go. Decent looking trough, a little bit pinched, but not bad, with winds. You need some winds, 130 knot winds pushing south, feeding development of that counterclockwise circulation, building to 140 knots into Tuesday, and then pushing its way into, we'll say, the Pacific Northwest into Thursday. You think it's all over, and then another backdoor trough starts setting up off of Alaska come Friday. This one, not as strong, not as much wind energy pushing south, but still, maybe something could develop from that. And it continues into Sunday, falling south, definitely very backdoor, but not very energetic, and then fading on Monday, but it almost looks like more energy might want to fall into it. So these backdoor troughs are the hallmark of low pressure. Typically, you want to see your big troughs off here in the jet stream well to the south. Instead, we see the jet stream very split, the northern branch way up to the north, these weird little backdoor troughs falling down the coast. So what these do help produce, though, is they drag cold air down with them, okay? And they also feed warm, moist air up from the tropics, and the intersection of the cold air and the warm, moist air helps produce precipitation. And at higher levels, because there's a lot of cold air behind it, that makes for more than normal snowfall, and typically lighter and drier snow. So this setup is kind of a good thing for the Cascades and the Sierra, at least for some snow production. Not so much for surf production, though. Anyway, rolling this out. We're at 180 hours out, and of course you can see major split in the jet stream here at 180 hours. High pressure likely in between the two flows. No real support for that would support significant gale or storm production. Let's take a look down at the surface, and as expected, high pressure, 1028 millibar in the Gulf, right in the middle of the Gulf of Alaska in fall. Not a good sign. Weak low pressure off the California coast, bit of a gradient producing 20-25 knot northeast winds, targeting Hawaii, maybe good for wind swell. Another little area, 20 knot winds off the Pacific Northwest, aims south. That's good for wind swell pushing into California, probably tomorrow time frame. And then this low pressure thing going on off Kamchatka, most of the fetch is all aimed north. Up there, doing nothing for our forecast area. 25 knot winds here off the Kuril Islands, and will not produce, what do you get out of that, an 8 or 9 second period swell? That'll be all decayed by the time it reaches Hawaii. Rolling this out, okay, our first low starts developing. Remember, backdoor trough here. Come Monday, winds 45 knots, pushing out of the north, falling south, continuing into Tuesday, 40 knot winds. Pretty good fetch right there, pushing midway between Hawaii and California, maybe a little bit more at California comes Tuesday night. And then the front, let's go back and take a quick look here. Here we go. The front from this gale pushes into the Cape Mendocino area with 35-knot winds Wednesday morning, pushing south to San Francisco, rapidly decaying 20-knot south winds Wednesday night, and it's all but over. Then a continued southwest flow into Thursday, and that sort of fades away. Next, backdoor trough develops on Friday. Notice 1040 millibar high, bulletproof, very strong there over the eastern Aleutians. Anyway, some weak 25-knot winds here, making for wind swell, maybe for Oregon, Northern California, maybe. I'm looking for any signs of anything else. Now, low pressure tries to develop. Remember, we're still in backdoor trough situation come Sunday. That's a week out. Wind swell, maybe for Hawaii out of this. And then at the last second on Monday, look at that, 35, almost 45-knot winds. And again, aimed probably better at Hawaii than California. But that's 180 hours out. Don't believe it. We'll see. Something to monitor during the week. Then we take a look at the effects of those winds on the ocean surface. As we mentioned before, rather placid pattern in control until the backdoor trough gale starts developing in the northern Gulf of Alaska on Monday. 26-foot seas build to 30 feet. There you go. 31 feet, right where the little cross is right there. See the cross? That delineates the maximum significant wave heights anywhere on this chart right there. So anyway, Monday night, 31-foot seas, 28 feet, falling south into Tuesday night, and then taking aim more on California. Some of this fetch certainly would spread into Hawaii, producing swell there, and then energy pushing into California into Thursday. That sort of fades out. The next system tries to organize, not nearly as strong. What is that, maybe 16-foot seas or so, till you get into later Sunday, and then we get a pulse of 26-foot seas aimed midway between Hawaii and California. We'll see what happens there. The short, not a whole lot going on, just one gale, and then maybe a second one with luck. Now, we're going to take a quick look at the southern hemi. Seems kind of late in the year, but sure enough, come last Wednesday, this is retrospective, we're looking back. Last Wednesday, a gale developed in the central South Pacific Ocean, 26-foot seas lifting northeast. You think it's all over, and then it reorganized, developed small area, very tiny area, 35-foot seas, pushing mainly east, and you think it's all over, then it redeveloped yet again, another small area, 27-foot seas, pushing off, and then another little system behind that. The net effect here is some swell is radiating north towards Southern California, though most of this energy is probably Central America down into Peru and Chile. Still, any swell, given the relative lack of anything else going on, is a good thing. And Southern Hemi swell, good for Southern California, seeing how they're going to be mostly shadowed from that Gulf swell if it develops as forecast. So maybe something good for Southern California. Northern California, probably most of the Southern Hemi swell will be lost in more energetic energy coming out of the Gulf of Alaska. Then current time, 18Z Sunday, looking at the forecast moving forward, tiny little, very small fetch, a tiny pebble being dropped into a rather big pond. Doubtful any energy from this will make up into Southern California. It's all moving off to the east and out of the California swell window by Tuesday. Another system develops falling south, nothing from that. Yet another system in the far southeast Pacific, 28-foot seas. Doubtful we'll see anything from that. Just not big enough, not large enough. And then things start quieting down 180 hours out. One would expect the Southern Hemi to start falling asleep at this time. Looking long term, what's going on with the MJO and El Nino La Nina? As usual, we start looking on the equatorial Pacific for signs of the MJO, the active phase specifically. This is the equator from east to west. East Pacific here, West Pacific here. Winds, trades out of the east, pretty brisk over the entire equatorial region, save for one little barb of west winds, highly suspect. Here's New Guinea, so say a little bit east of New Guinea. Anomalies, differences from normal for this time of year. A little bit of signs of more easterly anomalies. Trade's a little bit stronger than normal here in the East Pacific, and that's kind of expected during La Nina. And then also easterly anomalies in the Kelvin wave generation area. Kelvin wave generation area from 170 west off to about 135 east. 5 degrees north and south of the equator, right in this area. When you see east anomalies here, that suggests the inactive phase of the MJO. When you see west anomalies over a building region here, that suggests the active phase of the MJO. West anomalies help take moisture, evaporation off the equator, lift it up into the atmosphere. That gets infused into the jet stream. The jet stream gets more energetic. That helps create troughs. Troughs help create low pressure and, of course, storms in the Gulf of Alaska and the Dateline region during winter months, and sometimes in the southern hemi during southern months. But right now, this sort of suggests the inactive phase of the MJO is in control. What is the forecast for the next week? Well, okay, here's the whole planet. This is 850 millibar zonal wind anomalies. Whole planet on one chart. Kelvin wave generation area. Here's the date line. Here's 120 east. So Kelvin wave generation area, basically between these two tick marks, falling south. That is down this way. Blues, purple suggest easterly anomalies. This is zonal wind, the east and west component of the wind only. We don't care about north and south. Easterly winds, this is going back in time, October, in control. Here was the yellows and oranges, westerly anomalies, first batch of any westerly anomalies, and therefore the active phase of the MJO since March of this year. 6 months of nothing. And then all of a sudden in late October, it looked like the active phase of the MJO was starting to develop. And we all know that we got a flurry of southern hemi swells and northern hemi swells all in about a 2-week window from end of October into early November. But now you can see here's the beginning of the forecast. Deep purples setting up in the next 2 days. Easterly anomalies. Again, here's the Kelvin wave generation area right in this area here. Supposed to be in control and building, mainly isolated to the eastern Kelvin wave generation area, but still, it's the same thing. That no westerly anomalies indicated on the chart. Looking at other MJO indicators, the outgoing long wave radiation charts, yellow, so West Pacific here, East Pacific here, 2-week long forecast. Looking here, yellows and oranges suggest positive numbers, more sunlight reflectivity off the ocean surface. That means high pressure. That means the inactive phase of the MJO. Blues, less sunlight reflectivity, more clouds, low pressure. The active phase of the MJO, so one can sort of guess where the two phases are. The good news is this, per the statistical model, says the inactive phase, is supposed to die and be gone 2 weeks out with a neutral pattern in control. The GEEFS model suggests not only is that, but the active phase is supposed to move from the Indian Ocean into the West Pacific 2 weeks out. That would be good if it were true. That would help feed jet streams and storm development. Phase diagram charts here. So assume you're looking down on the North Pole. The MJO moves from west to east, from the Indian Ocean over the maritime continent, across the Pacific, on the equator, under the United States, across the Atlantic, over top of northern Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is right now. So let's say the East Indian Ocean. If you're inside this circle, though, it's considered to be exceedingly weak. The green line is the forecast, suggesting the active phase of the MJO is maybe supposed to make an appearance in the far West Pacific 2 weeks out. This per the ECMF model. The GEFS model suggests maybe the active phase is to be a little bit more coherent, make it across the Indian Ocean, and then into the West Pacific, and then weaken. So two different variations on the same thing, not a whole lot of difference between them. The upper level model suggests, okay, so here's West Pacific here, East Pacific here, South America, New Guinea, Philippines right there. The oranges and yellow, areas not favorable for precipitation, dry, meaning the inactive phase of the MJO. And this runs about a week or two ahead of what actually goes on down the surface, suggesting a dry pattern, inactive phase right now, working its way into Central America through just about before Thanksgiving, November 20th. That same time, the active phase of the MJO supposedly starts developing in the West Pacific, but rather incoherent, but making its way across the Pacific into, let's say 10th of December or so. So maybe there's a window here, late November, early December for some storm development. And then we get into, let's say, the 5th or 10th of December, and then the inactive phase starts developing in the West Pacific again. So a little bit different take on the long-term outlook. This is a 40-day outlook. And then even a longer outlook, this from the CFS model, 850 millibar winds. So here's where the Kelvin wave generation area, roughly right in here. This is the whole world on one chart. The forecast is moving to the top of the chart. Blues are easterly anomalies in control, and that's what we saw in the other model for the next week. That's about right. That's consistent with what we saw. We'll overlay the MJO. Now, this suggests that the active phase of the MJO moving out, inactive phase, these dotted contours, that's the inactive phase, moving in, easterly anomalies in control for about a week, and then somewhere, maybe November 13th or so, weak westerly anomalies, even though the inactive phase, one is supposed to fade and then redevelop again, still maybe a little window somewhere in here, the late November time frame. Then easterly anomalies develop again in the far West Pacific. But then as we get into mid to late December, active phase of the MJO tries to organize and then reorganizes yet again. Stronger westerly anomalies. Of course, we're not going to believe any model that's going out into the January time frame, but it suggests that probably maybe a weak little window here in the late-ish November time frame, and then after that things pretty quiet until we get into the Christmas time frame or so. Also, low-pass filter. This is somewhat interesting to note. The dotted contour here suggests area that's more supportive of high pressure. We typically think of it as the La Nina area, if you will. Let's go see. Here is the date line. You can't see it. It's off the... maybe we can scroll it up here. There you go. There's the date line right there. The Kelvin wave generation area starts over here, and you see when you get into about November, this area, this is an area supportive of low pressure, starts moving into the West Pacific and right in here. So after about Thanksgiving or so, there's more potential in the far West Pacific to support gale development and storm development and low pressure development. Now, that we don't know that that's necessarily going to feed the jet stream. It kind of looks like La Nina is in control, but let's see. So, we'll roll down here so you can see what's going on. 180 is roughly about here. You can see this high pressure field is almost moving out of the Kelvin wave generation area completely come late December, which would suggest that maybe if we're going to get any storm development, that it might start happening, and in some sort of sustained manner, maybe right around the Christmas time frame and thereafter. So something to look forward to. Don't believe a model this far out, but this pattern's been holding for months now, or at least, a month or more, and maybe there's some credence to it. And one last piece on the MJO. This chart depicts the strength of the MJO, active phase, not where it is, just the strength of it. Last time we had a good active phase of the MJO was here back in March, and then remember, April, May, June, July, August, September, into early October, nothing. Southern Hemi was asleep. Northern Hemi did nothing. Until we got to that spurt somewhere in early mid-October sort of thing. Things went nuts. Southern Hemi woke up. Northern Hemi woke up. We had swells coming from all different directions. And then as quick as it woke up, boom, it's back asleep now. Inactive phase of the MJO in control, and our spike is over. So this is just an interesting footnote. You can really historically look back and see the effect of the MJO on storm production using a chart like this. So next up, let's take a look and see what's going on in the oceans, because the atmosphere affects the oceans affect the atmosphere, the two of them interact, have a dependency. In the West Pacific here, East Pacific here, we're looking at depth in the ocean on the equator, 2 degrees north and south. These are the anchor lines off the TAO buoy array strung across the equatorial Pacific. The X's are the sensors on those buoy anchor lines, and that's how you get a sense of what the temperature profile is in the Pacific. Warm water, of course, here, 29 degrees Celsius, balled up in the West Pacific, driven by strong trades at the surface. That also creates upwelling in the East Pacific, a much shallower warm water pool, if you want to call it warm, much cooler, and that's pretty typical of La Nina. Looking at anomalies, differences from normal for this time of year, we see cool water at depth, likely upwelling to the surface. The 0 degree line difference between cooler waters and warmer waters is at about 160 west, let's say right there, or south of Hawaii. Warm water, 2 degrees at depth, above normal in the far West Pacific, 3 degrees below normal in the East Pacific, and that is pretty much the hallmark of La Nina. Another model using that same data suggests the cool pool is actually even stronger. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4 to 5 degrees below normal in one little pocket here. You can see it upwelling to the surface. Just imagine east winds blowing hard along here, pushing warm water off to the east. There's a building warm pool there, and then cool water at depths. You can see the fingers of it reaching up into the surface, and keep this in mind when we look at the surface temperature charts. Sea level anomalies, strip out all the waves, strip out wind waves, strip out tides, and you see the height of the ocean's surface unrelated to waves. And what you see is 10 centimeter anomalies below normal, sort of a divot in the ocean surface over a large area on the equator here. That suggests cold water at depth. Cold water, of course, contracts at depth, and that causes the divot. Warm water expands, causes a bump in the surface. So this suggests cool water at depth. Upper ocean heat anomalies. Last year, some warm water, remnant El Nino-like warm water still in the far West Pacific. Cool water here in the East Pacific, East trades. We got 2 pulses in March and May, June of last year of almost like a mini El Nino, but it really wasn't. And that fully just discharged the warm pool, and then La Nina set in. Right here we are, current time. Cool anomalies in the East Pacific to a point south of Hawaii. Notice a little bit of building warm anomalies. We'd like to see a lot more of that, because the sooner that starts building and really strong, then that'll set us up for at least normal temperatures, and then hopefully long term. You need 4 years of this going on until you get an El Nino. We're a long ways away from that. But the idea is just to get this La Nina over with and get us back into a pattern that's more normal. Surface temperature anomalies, blues, below normal, pretty well below normal, somewhere in the maybe 2 degree in pockets. So this suggests significant upwelling along the coast of Peru, the typical of La Nina. And you can see, remember, there's high pressure here, circulating counterclockwise in the southern hemisphere, clockwise in the northern hemisphere, and if it's stronger than normal, trades are blowing a lot harder than normal here, causing upwelling off the coast of Peru, and that cool water just starts moving across the equator and out. This cooler water means less evaporation, less energy moving up into the atmosphere, less feeding of the jet stream, less fuel for the jet stream, and so you end up kind of where we are with not a lot of storms and not a whole lot going on. The trend for the last 7 days suggests temperatures, the sea surface temperatures, cooling in pockets. The balance is probably more cooling than warming, and so that's probably not a slight pulse of La Nina. And then the overview, a clear delineation of La Nina. This is classic La Nina. If it was El Nino, you'd see warm water all in here. Now we see much colder than normal, just snaking its way across the equator. And, what can you say? This is maybe even a hair bit stronger than it was last week. Not unexpected. And here we go, sea surface temperature anomalies in the Nino 1.2 range. This is off of Peru and Chile. The trend, downward. Down the lowest we've been so far this year 2.2 degrees below normal. All it takes is half a degree to get you La Nina. Now, not in this region, but this is sort of the noisy generation area of La Nina, if you will, and suggesting much cool water off the coast of Peru. And this, sea surface temperatures for the Nino 3.4 region, the main El Nino monitoring region. Temperatures currently 0.464, about half a degree below normal. The trend, looking at it though, sort of looks like things are stabilizing, maybe dropping slightly. This is sort of good news, but we fully expect temperatures to continue to drop based on models, based on everything we're seeing. This is likely the most positive outlook. Next, we take a look at the Southern Oscillation Index. What's going on with the atmosphere above the ocean? We know we have cooler water on the equator, and it very much looks like La Nina. Let's see if the atmosphere is responding in kind. Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Positive numbers, daily index here. Positive numbers over a long period of time suggest the inactive phase of the MJO, and even over a longer period of time suggests La Nina. Current value, plus 9.73, and pretty good run of numbers in that region lately. The 30-day running average, looking for the presence of the MJO, positive, the warm phase or the cold phase, currently at 8.42, suggesting the inactive phase of the MJO. This would have to be negative to be the active phase. And then the 90-day running average, looking for the presence of El Nino, La Nina. Positive, but not horribly so, 7.44. If it was up around 10 or 12, then that would definitely suggest La Nina. We think we're going to get there by the time we get into December. Not there yet, though. And then finally, the ESPI index. Much like the Southern Oscillation Index, instead of measuring the difference in pressure between the area north of Darwin and the area north of Tahiti, we're measuring the amount of precipitation, rainfall anomalies right in this area here. You can see it looks pretty dry. The figure, minus 1.02. That definitely suggests dry, less precipitation, whatever the minus one standard deviation below normal, suggesting La Nina. And then finally, the sea surface temperature forecast, Nino 3.4 region, the main area for monitoring El Nino, suggests we were at half a degree below normal in October. We're on a steady downward decline, going down to maybe 1.1 degrees below normal in January. Now, the interesting part this week is this thing was supposed to bottom out at 1 degrees at the end of December and then start rising from there. Now, the forecast suggests negative anomalies going through the whole month of January, not starting to rise till February. That's pretty more typical of a normal La Nina. No big surprise there. So this clearly suggests that we're in La Nina and that we're going to stay in La Nina for the entirety of this winter. We've all known this was coming. And we've known for a while that we're in La Nina. We expect that. We're just going to have to suck it up and live with it this winter. We hope that we get enough backdoor troughs to at least get some snow in the mountains, keep the our water reservoir building relative to California. Maybe we'll get some storms if the MJ will pulse active at times, but in between those pulses, probably not a whole lot of storm or gale activity. Get wind swell where you can, make the most of it. Just get through this winter is the idea. We think that once we get into about the late summer of next year, things will start stabilize and return to a more normal pattern. By next winter, things should be in a little bit better shape. There'll still be some hangover effects in the atmosphere from La Nina. Just because it shuts down doesn't mean it's all over. But next winter certainly should be better than this winter. So the thought is this is as bad as it's going to get. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.